Alright, new entry in the journal. So, today is June 19th, 2021. Current state of affairs with my drone. What you're looking at is the actual everything that is going to be inside the first version. The first version does not include Raspberry Pi. So I'm only operating essential components, which is this is Arduino, the main brain. This is my gyroscope, so I know the position. This is my GPS with the antenna. This is my sensors for the leakage provided by the robotics. Oh, not provided, I bought it. But this is my also the sensors from them for the pressure, and I will show you the bottom cap that I already printed for the body. This is um, the voltage controller and divider, basically to run the battery, and this is my NRF24 radio transmitter. There's a second layer right there. This is the battery, and I'm running this to the power. So it's already printed as you see, so it's all connected by these kind of very simple Lego like legs and hooks, just rubber bands, because I want everything to be quick. And I installed the Velcro for all the components, so I can easily move them the way I want. And if I need to add more, I always have space, and I can readjust it quicker than using bolts and stuff. And this strip is gonna be just to share power, 5 volt among all of them. So yeah, it's very easy design. The battery, you know, everything is here, nothing is moving, so it does its job. And I don't expect to be any turbulent movements, but we will see, the time will show. Alright, and now I'm going to show you the um, the body, the bottom cap, basically. That's how it looks right now. You see this color, this job. So basically what happened is I'm printing everything. There's Friday printing right there. It's actually I'm printing a top body right now, and it's gonna take 4.5 days to finish printing it. I'm already like day and a half in, and it's printing the top body right now with walls and everything. So if you can see here, in order to not fuck up the bottom layer, because it always does the 11-foot fuck ups, I'm just raising it up a little, and it's supposed to be 5 millimeters, but it squashes the 11-foot. That's why it's less than that. And last time I had a very hard time getting rid of it after the print, which took like 3.5 days. In 3.5 days, the bottom layers, because it's constant temperature, I would assume that they just getting worse and worse, and like they just get baked in slowly, and it's very hard to get rid of them. So if you can see right here, I still have some very lost layer. I'm using the tree support. So for in 3D printing settings, it's using the tree support to create the build-up, because I have a very small pin just raised up for 5 millimeters. So it builds up the entire tree um, surface support area around the thing, just to support those 5 millimeters of the raised structure that I built. So it's building this tree support, and the very last layer that it does, it's made in this. The tree is so random, but the very last layer is all like that, like a grid, square grid, and it supports the entire thing. So it was very hard to get the sprint off the glass plate in the first place. I had to like fucking wrestle with it, and then I got it off, but it had all this debris with the tree support layers and this layer, so I had to just grind it down. And the grinding paper was of red color, and it left stains like that. So, anyways, I mean, it's not gonna interfere with my research, anyways. So I left it like that, and it was very hard to grind this part. I was like, "Fuck shit." So this is the pressure sensor from Blue Robotics. Actually, the sensor that will be sticking out. In the future, there will be a hold for video camera here as well, and all anything else that I will include, such as most likely for some um, lighter or sound um, radar devices like ultrasound because it's in water. Alright, so what's inside? This is the connector that goes into that chip that I showed you earlier. It has 3 pins, and they already broke off right here, like these pins right here, so I had to use screws to screw them back in. So that's a design kind of weakness on my part. And it has 3 holes for wires that will go to motors. Currently they are sealed with silicon because I want to, once the top body tests prints, I will be testing if the seal can hold the pressure. So I need to minimize um, the channels that the water might come through, so these holes are all sealed, so I don't have to worry about that. I also initially I wanted to do like it's either like 3 ridges kind of system, 1, 2, and 3. So the opposite body side will have 3 kind of dad walls that will go in. The system proven to be very hard to use because in between of these 2 ridges, like this ridge right here, right, like the gap right here, it's very hard to reach to put the silicone. My idea was to put the silicone on the very bottom of each gap, so when the top head presses down on it, then it presses down on the bottom layer, which is silica, and seals it that way. And I'm gonna have like the straps to pull it down to squeeze it in. So it was supposed to push into the silicon and create pressure that way, but it's very hard to reach this gap. Like I made it too small and I don't want to reprint it, so what I decided to do is to just fill the entire gap with the silica. And I'm printing right now. The body would have not 3 walls but just 2 outer walls, and the center would have just a little kind of um, ball that will be sticking out just a little bit, a couple of millimeters, just to get inside, but it's not gonna go all the way through. This thing is gonna be like this gap right now will be filled with silicon, and it's just gonna push right here, and the other walls will push right there, so it should be working out good. Also, the when it's like that, it's proven to be very fragile. You see right here, I need to use super glue to glue this together. I already super glued the other ones. They seem to hold well, but not this one for some reason. and also put silica on the outer edge right here. That's the plan, I guess. So yeah, that's the current state of my production. So what I need to do today is connect every sensor, make sure that the system works, and few things that happened before that I didn't journal about, unfortunately, is my idea was to have the drone, or the scout as I call it, to be completely underwater all the time. The problem that I run into, that I should have researched, but I was doing my way, which is like try first and then find out about it. Um, Turned out that the radio frequencies of my NRF 24 receiver don't give, they don't, you cannot penetrate the water with radio frequencies. You can only use ultrasound or some sound, sound waves basically. But sound waves don't penetrate the air; they get reflected off the surface of the ocean. So it's a pickle, and actually, no submarines can communicate with the outer world. I understand even as of now, but maybe they reach that. I'm not sure, but definitely not the technology that I can build right now. So, but I don't need this. I don't need this to be a submarine. My purpose is to photograph the bottom ocean, not to stay stealth. So I can easily, what I decided to do is to have this drone, have this count to be like a mammal in the ocean. So you go down, you gather information, you photograph the bottom ocean, the bottom floor, and then you raise up. You, because this thing would be actually buoyant. I had very hard time putting it in a um, plastic like seal, those seal bags that you use for kitchen stuff. So I was putting this that, and that had some air inside. No matter how I folded it, still there was some. I don't have a vacuum to vacuum the air out to create the vacuum there. Um, Interesting vacuum cleaner. Anyways, um, so yeah, it was very hard time to actually submerge Arduino in that plastic bag inside because the air was just push it up. I had to tie the like huge. I have a huge glass bottle from kombucha, like 2 liters or something, and I um, filled it with water, tied the Arduino in a plastic bag with it, and it still barely could submerge the entire thing. So buoyancy is a real bitch. That's what I learned too. Um, and yes, the Arduino, the moment you pop up from the water, it starts transmitting the signal. The moment you submerge it, it's done. That was the experiment um, that I did with Alex Paul. Thank you so much for collaboration, K Club. Um, that's it. Right now, I'll be testing this. I would need to also resolder. You see how easy it is like to get this thing? You just have to pull it out and you have this. So I'll be resoldering this side onto the other side so it will be easier connection with the battery. Um, and I'll be connecting one by one everything for the tests. Also, I'm thinking the current arms that I have for the um, engines, they're too long. and I want to shorten it so the engines will be much quicker, much closer to the body itself. So probably instead of this length, it would cut right here. So this is what is gonna be left. Like the majority of the thing will go off because first of all, it minimizes the risk that the motors will, by pulling towards different direction, it um, focuses all the damage power on the fixture right here, and I'm afraid that it's gonna just fuck up the fixture and it's gonna break faster than it's intended to. And the second thing is it's just too wide to carry it, like it's too extending. Now the counterpoint that might be is somehow, and again it's not tested because I'm dumb and I didn't read anything about this, but um, the counterpoint to what I'm intending to do, which is shorten it, to the counterpoint to keep it this way or to keep it away from the body is the motor will have more water around it to pull through, and if you get closer to the body, you create this kind of pressure point where there's not that much water going on. So the motor, um, by pulling the water that is close to the body, I presume the pressure point of this water or the speed of the water here will be completely different than the speed of the water around it, where there's nothing interferes, where the water can replenish the uh, the point in space that it's getting pulled from many other sides. So I guess by pulling the engine, that by designing the engine closer to the body, I'm destroying the balance of the kind of the force of the reactive force of water versus engine. But I don't give a fuck, you know. I'm a gangster. This shit. So that's the current state. And again, it's June 19th, 2021. Thank you so much. See you soon.